For decades, the Voyager 2 spacecraft has been an incredible testament to human ingenuity, exploring the farthest reaches of our solar system and beyond. Launched in 1977, it has traveled over 18 billion kilometers from Earth, making it the second farthest human-made object from our planet. Voyager 2 has provided us with unprecedented data about the outer planets and continues to send signals back from the distant edges of our solar system. But recently, scientists discovered something that could change everything we thought we knew about the spacecraft's future. A mystery that has baffled engineers and space scientists for years was finally solved. However, the revelation is not good news, and it raises more questions than answers. Let's dive into the latest findings surrounding Voyager 2's mystery, what they mean, and why this could be the beginning of a difficult and uncertain future for the beloved spacecraft. The Voyager program was designed to explore the outer reaches of our solar system, providing us with invaluable information about the gas giants like Jupiter and Saturn, as well as their moons. Voyager 1, which launched shortly after Voyager 2, is now the furthest spacecraft from Earth, while Voyager 2 is traveling in a different trajectory, heading out of the plane of our solar system. But as Voyager 2 ventured farther from Earth, it began to experience a series of mysterious issues that left scientists scratching their heads. Initially, the spacecraft's status was stable, sending back data from deep space. But around 2019, something changed. Voyager 2 was, for the first time, more than 18 billion kilometers away from Earth. And engineers noticed something unusual. The spacecraft was sending back erratic signals that were not consistent with its expected behavior. The anomaly caught the attention of NASA's Jet Propulsion Laboratory, which oversees the Voyager missions. Voyager 2 was still sending signals, but something was off. The spacecraft appeared to be sending less data than usual, and its attitude control system, responsible for maintaining its orientation in space, was malfunctioning. This was concerning because any loss of orientation could lead to the spacecraft becoming unable to communicate with Earth. It was a race against time to figure out what was happening before Voyager 2 drifted further into the depths of space without any hope of contact. At first, scientists believed the issue might have been related to the spacecraft's power source. Voyager 2 is powered by nuclear batteries, which decay over time. This is a common concern for long-term space missions, as the power generated by these batteries slowly diminishes. However, after conducting a series of tests, it became clear that the power issue was not the cause of the problem. Instead, the mystery seemed to be linked to the spacecraft's aging electronics and its communication system. For a while, scientists were unable to pinpoint the exact cause of the anomaly. The spacecraft was so far out that sending engineers to fix anything was obviously impossible, and there were no immediate solutions that could fix the problem remotely. Then, in late 2020, after years of uncertainty, scientists made a breakthrough. They discovered that the problem was actually related to the spacecraft's attitude control system, a system that keeps Voyager 2 properly oriented so it can continue to communicate with Earth. This system is powered by a series of gyroscopes, which help the spacecraft maintain its orientation in the void of space. The issue was that one of these gyroscopes had failed. At first, this seemed like just another malfunction to deal with in a mission that had already surpassed its expected lifetime by decades. After all, Voyager 2 was originally designed to last only 5 years in space. It had far outlived its mission parameters and had become an unexpected success. However, this failure wasn't just a minor setback. Without a functional gyroscope, Voyager 2 couldn't properly orient itself to face Earth, making communication more difficult. It was still able to send faint signals back to NASA, but those signals were weaker and less reliable than they had been in the past. What followed was even more concerning. After a series of troubleshooting attempts, NASA engineers were able to figure out a way to stabilize Voyager 2's orientation. They used a backup system that had been implemented as a contingency for such malfunctions, and for a while it seemed that everything was back on track. The spacecraft's communication resumed at a more consistent rate, and scientists were hopeful that they had avoided a permanent loss of contact. But in the summer of 2022, things took a turn for the worse. Voyager 2 once again sent back an unexpected signal that left scientists puzzled. The spacecraft's communications had been restored, but a new problem arose: a critical failure in the spacecraft's backup systems. This time, it wasn't a gyroscope malfunction, but an issue with the spacecraft's onboard computer systems. Voyager 2 had been relying on a combination of hardware and software to maintain its operations, but as the spacecraft aged, the risk of system failures only increased. The computer that controlled many of the spacecraft's functions was becoming increasingly unstable. This was the heart of the mystery scientists had been trying to solve for years. Was it just an issue of old equipment? Or was there something deeper going on with the spacecraft's systems that hadn't been detected before? As engineers dug deeper into the problem, they discovered that the onboard software, which was responsible for adjusting the spacecraft's functions in real time, was also deteriorating. The spacecraft's programming was becoming increasingly incompatible with its aging hardware, leading to the erratic behavior of the spacecraft. NASA's team knew that the situation was critical. Without the onboard computer systems functioning properly, Voyager 2 would be unable to process and transmit the valuable data it had been collecting over the years. More importantly, it would be nearly impossible to regain contact with the spacecraft if its systems failed entirely. That was when scientists realized something even more unsettling. They had been assuming that Voyager 2 could continue to function for a few more years, perhaps even a decade. But with the rapid degradation of its computer systems and communication equipment, the reality was much darker. The spacecraft was quickly approaching the end of its mission, and not because it was running out of power or fuel. No, the real problem was that the equipment on board was simply too old and too fragile to withstand the harsh conditions of deep space. Voyager 2's mystery had been solved, but the answers were anything but reassuring. The spacecraft, once the pride of humanity's exploration of the cosmos, was facing an irreversible decline, and there was nothing scientists could do to stop it. The truth was clear: Voyager 2's mission was coming to an end. In response to these challenges, NASA made the difficult decision to scale back the spacecraft's operations, prioritizing critical functions over less essential tasks. Communications with Earth became increasingly sporadic as the spacecraft's systems continued to deteriorate, and even the most basic functions of the spacecraft became a challenge. But it wasn't just the technical issues that were troubling. The reality that Voyager 2, one of the most remarkable human-made objects ever built, was reaching the end of its life hit hard for many involved in the mission. It was a bittersweet moment for those who had worked tirelessly on the Voyager program for decades. Voyager 2 had been an extraordinary success, a shining example of human perseverance and curiosity. However, the true weight of the situation wasn't just about the loss of the spacecraft. It was about what Voyager 2 represented: the end of an era in space exploration. For over 40 years, Voyager 2 had served as a bridge between humanity and the unknown, a symbol of our desire to explore the stars. But now, as it hurtled toward the outermost reaches of our solar system, it was clear that its journey was nearing its end. The legacy of Voyager 2 is undeniable. It's a legacy of exploration, of pushing the boundaries of what we thought was possible. But the reality is, as with all great missions, there comes a time when the end is inevitable. Voyager 2's once cutting-edge technology has now become outdated, and the spacecraft is running out of the resources it needs to continue its vital work. But the story of Voyager 2 doesn't end with its final transmission. Even as the spacecraft's systems fail, the data it has collected will continue to shape our understanding of the cosmos for generations to come. Voyager 2's journey may be nearing its end, but its legacy will live on as a reminder of humanity's ability to dream big and reach for the stars. So, what's next for Voyager 2? Sadly, it seems that the spacecraft will soon be lost to the void, fading away in the depths of interstellar space. But while its communication may end, the data it has sent back will continue to be analyzed by scientists for years to come, unraveling the mysteries of our solar system and beyond. In the grand scheme of space exploration, the story of Voyager 2 is just one chapter. As technology advances and new missions are launched, we will continue to push the boundaries of our understanding. Voyager 2 may be nearing the end of its journey, but it has paved the way for the missions of tomorrow. The mystery of Voyager 2 has been solved, but the news is not as hopeful as we had hoped. The spacecraft is facing its inevitable end, and its once advanced technology is finally succumbing to the harsh conditions of deep space. However, even as we say goodbye to Voyager 2, its legacy will endure, inspiring future generations to continue exploring the great unknown. The mission may be over, but the dream of exploration lives on. Voyager 2's story is a reminder of the incredible human spirit, of our ability to reach for the stars, even when it seems like we're too small to matter in the vastness of space. And in the end, that's what makes its journey so remarkable. Not just the distance it's traveled, but the way it has captured the imagination of millions, pushing us to wonder about what lies beyond the horizon. The journey may be ending, but Voyager 2's impact will never fade. And that in itself is a victory. The Voyager missions have always been a symbol of humanity's endless curiosity and drive to explore the cosmos. When Voyager 2 was launched in 1977, it was meant to be a once-in-a-lifetime opportunity. The mission was daring and ambitious, tasked with sending back critical data from Jupiter, Saturn, Uranus, and Neptune, planets that no spacecraft had visited before. Voyager 2's journey through the outer solar system unveiled many mysteries, answering questions that had plagued astronomers for centuries. For example, Voyager 2's flybys of Jupiter and Saturn revealed the incredible dynamics of these gas giants. With their intense magnetic fields, swirling storm systems, and spectacular rings. It was Voyager 2 that gave us our first close-up images of these planets and their moons, showing us worlds like Titan, one of Saturn's moons with its thick atmosphere, and Europa, a moon of Jupiter, which may harbor the conditions necessary for life beneath its icy surface. But the spacecraft didn't stop there. Voyager 2 was the only spacecraft to fly past both Uranus and Neptune, making critical discoveries. It showed us the planet Uranus, which had previously only been observed through telescopes, revealing a world with a tilted axis that causes its seasons to last decades. Then, as it passed Neptune, Voyager 2 captured stunning images of the planet's moon, Triton, and provided new insights into Neptune's atmosphere and weather patterns. The iconic image of Neptune's Great Dark Spot, a massive storm system similar to Jupiter's Great Red Spot, was among the first of its kind, proving that there was so much more to discover in the farthest reaches of our solar system. Voyager 2's discoveries were pivotal for expanding our understanding of the solar system. But there's another major aspect of its mission that's often overlooked: the spacecraft's golden record. Attached to both Voyager 1 and Voyager 2, the golden record is a message to any intelligent extraterrestrial life that might one day discover the spacecraft. The record contains a diverse collection of sounds and images, everything from greetings in 55 different languages to sounds of the Earth's natural world, music from different cultures, and even the human heartbeat. It was an ambitious effort to create a time capsule for humanity, a reminder of who we are and where we came from. Voyager 2's golden record wasn't just about sending a message to the stars, it was about making a statement. It was the ultimate symbol of hope and possibility, a testament to humanity's optimism in our place in the universe. The record encapsulated the dreams of explorers, scientists, and dreamers alike, showing that even in the vast cold emptiness of space, humanity could leave a mark. Voyager 2 was our emissary, reaching out into the unknown with the potential to be discovered by extraterrestrial civilizations millennia from now. Yet now, as we look back at the spacecraft's journey, it's hard not to feel a sense of inevitability creeping in. The technology that once made Voyager 2 a marvel is now its greatest limitation. While the spacecraft's power source, its radioisotope thermoelectric generator, RTG, has kept the spacecraft functional far longer than expected, its systems are slowly failing. Every year, the spacecraft's power output decreases as its radioactive fuel decays, and the spacecraft must prioritize which systems remain operational. Voyager 2's communication system, which once sent crisp data from deep space, now struggles to maintain consistent contact with Earth. The spacecraft's ability to send back data is growing weaker, and the time it takes for its signals to reach Earth is increasing. As of now, it takes more than 18 hours for a signal from Voyager 2 to reach our planet. That time delay only compounds the difficulty of managing and troubleshooting the spacecraft remotely. If a critical issue arises, it's not as simple as fixing it immediately. It takes a team of engineers hours, days, or even weeks to work through the issue, all while the spacecraft is drifting farther from us, beyond the reach of most of the tools and techniques we've developed to maintain spacecraft. Another problem that has begun to surface is that some of the equipment on Voyager 2 is aging in ways that weren't anticipated. When the spacecraft was first launched, its systems were cutting edge. However, technology has changed dramatically in the nearly 5 decades since, and parts of Voyager 2 are now beyond their expiration date. Components like the onboard computer and sensors, designed to last for a few years, have outlived their expected lifespan many times over. Even more alarming is the spacecraft's fading ability to adjust its orientation in space. The attitude control system that once used gyroscopes to keep the spacecraft aligned with Earth is no longer fully functional. This system was crucial because it allowed Voyager 2 to point its antenna toward Earth, ensuring it could transmit data back to us. When one of the gyroscopes failed, engineers switched to a backup system. But as we've seen over the past few years, this backup is not a permanent solution. In fact, these failures raise a more significant question. As Voyager 2 moves farther into interstellar space, how much more can we really learn from it? While its historic flybys of Jupiter, Saturn, Uranus, and Neptune were groundbreaking, we've already gathered most of the information we'll ever get from those regions. The spacecraft is now in an era of slow decline. The mystery that had puzzled scientists for so long, the source of the strange and erratic signals, has now been explained, and the answer is clear. The spacecraft is simply too old to keep up its once impressive pace. But before we get too gloomy, it's important to understand the immense value of what Voyager 2 has given us. Its mission has far exceeded expectations. NASA originally estimated that it would only last 5 years in space. But here we are, nearly 50 years later, still receiving signals and data from a spacecraft that was never designed to operate beyond a few years. Voyager 2 has far outlived its creator's wildest dreams, and in that time it has radically expanded our understanding of the solar system, of deep space, and of the universe itself. Despite the recent problems, Voyager 2 continues to send back data from beyond the reach of our solar system. It has now entered a region of space known as interstellar space, the area between the stars. For the first time, humanity has a direct line of communication with the vast void between the stars. While Voyager 2's data isn't as fresh or as reliable as it once was, it still offers scientists the opportunity to study a part of space we've never explored before. In 2018, Voyager 2 crossed the boundary known as the heliopause, the point at which the solar wind from our Sun becomes too weak to influence the surrounding space. This marked a momentous milestone. Voyager 2 was officially the second human-made object to enter interstellar space. Only Voyager 1, which crossed this boundary in 2012, had done so before. But while Voyager 1 has been busy sending back valuable data about the conditions of interstellar space, Voyager 2 has its own unique perspective. Voyager 2's crossing of the heliopause allowed scientists to measure the properties of the plasma, cosmic rays, and magnetic fields that exist in interstellar space. These measurements are vital because they help us understand the larger context of our solar system in the universe. we're beginning to understand the environment in which our solar system resides, and that knowledge will help guide future interstellar missions. Voyager 2's location in interstellar space also presents a unique opportunity to study cosmic rays and other phenomena that originate outside the solar system. Scientists have already begun analyzing these cosmic rays in more detail, providing us with new insights into the nature of these high-energy particles. For instance, the spacecraft's instruments have helped scientists observe an increase in cosmic ray activity as it nears interstellar space, indicating that the solar system is not a static environment, but is constantly interacting with the interstellar medium. Voyager 2's instruments are also revealing details about the magnetic fields in this region, which will be crucial in understanding the broader galactic environment. However, there's a bittersweet element to all this. The longer Voyager 2 remains active, the closer it gets to the end of its mission. Every day, its power diminishes, and its systems degrade. Engineers are now facing the challenge of preserving the spacecraft's functionality for as long as possible. They've already started to shut down non-essential systems to conserve power, ensuring that Voyager 2 can continue transmitting data for as long as it can. But inevitably, that power will run out. The systems will fail, and the spacecraft will go silent. When that happens, the spacecraft will continue its journey through the stars, forever adrift in the interstellar medium, just as the golden record aboard it intended. But no longer will it be sending messages to Earth. No longer will it be sending data that could shape the future of space exploration. Instead, it will simply be one of the many silent travelers in the vastness of space, carrying with it the legacy of human exploration. Even as we bid farewell to Voyager 2, there is hope on the horizon. New missions such as NASA's New Horizons are continuing the journey of exploration that began with Voyager 2. But even as new spacecraft venture into the unknown, there is something uniquely profound about Voyager 2's mission. It was humanity's first real attempt to reach out into the great unknown and discover what lay beyond our planet. Voyager 2 may no longer be the spacecraft we once thought it would be, the vibrant, constantly sending back incredible data from the edges of our solar system. But its legacy lives on. As we continue to learn more about the stars, the planets, and the universe beyond, we can thank Voyager 2 for being there first, taking those first steps into the unknown, and showing us just how much we still have to discover. It may not be the end of its mission, but it's certainly the beginning of a new chapter for human space exploration. And so, while scientists have finally solved the mystery of Voyager 2's communication problems, and the end of its mission is inevitable, the spacecraft's legacy will never be forgotten. It will continue to inspire us to explore, to dream, and to push the boundaries of what's possible, even if that means sending our creations into the vast, empty spaces between the stars. In the grand scheme of things, Voyager 2 may be coming to the end of its journey, but its impact will endure for generations to come.